the number of times that we folded the paper, and f of n is the thickness of the paper in millimeters. So when you initially get the paper, you haven't folded it, right? So it's going to be 0 folds, and it's 0.1 millimeters. Then when you fold it once, it's twice as big. You fold it again, and it's twice as thick as the previous one, so it's going to be 0.4, and it's going to go on. Okay? So for the explicit rule, we're going to say f of n equals the first number times the ratio. So the ratio to go from here to here is you times 2. And again, it tells you the paper is twice as thick, so we're doubling. To the n minus 1 for all n greater than equal to, since we started with 0, take it back, it's the first number and then the ratio to the, let me fix that, to the n, for all n greater than equal to 0. So that would be the explicit rule. For the recursive rule, you have f of 0 equals 0.1, and then f of n equals the ratio times f of n minus 1 for all n greater than equal to 1. Okay, so for B it says studies have shown that you can fold a paper a maximum of 7 times. How thick will the paper be if it's folded on top of itself 7 times? So for n is 7. So you're going to take f of the explicit formula or the rule, and you'll put f of 7 equals 0.1 times 2 to the 7th, and so that's going to give you, put in the calculator 2 to the 7th and then multiply that by 0.1, and so that's going to give you 12.8 millimeters. Okay, and then part C, assume that you can fold the paper as many times as you want, so it's unlimited. How many folds would be required for the paper to be taller than Mount Everest at 8,800 meters? Okay, so remember, you got to be careful with units. 8,800 meters is 8,850,000. Oh wait, did I copy it right? Yeah, millimeters, because there's 1,000 millimeters in a meter. So we're going to set up our equation. We're solving for n because it's asking you how many folds. So what is the n value, okay, for the paper to be taller than Mount Everest? So how many times would you have to fold the piece of paper? Okay, so we have the height is 8,850,000. It equals 10th ratio to the n, like that. So first thing we do, we're solving for n, right? Let me switch the color. I'm going to divide by 1/10 to leave the 2 to the n by itself. And so that leaves me with 88. When you plug it into a calculator, again, you're dividing by 0.1. So you end up with 88,500,000. And at this point, because you haven't studied logs this year, we're going to just guess and check. So 2 to what power gives us 88,500,000? Again, try 2 to the 20, let's say. So 2 to the 20 is 1 million something, so too small. And try 2 to the 30 then. Well, 2 to the 30 is a billion too big. Okay, so then we'll try 2 to the 25. We'll go in between. 2 to the 25. And that gives us 33 million. Okay, so we want to get to 88. So this is 33 mil. I'll just put for million. And then 2 to the 26. Let me see. 2 to the 26 is 67 million. Okay, and so we do try 2 to the 27. So just keep trying different numbers, and this gives us 2 to the 27 is 134 million. Too big, right? So 2 to the 26 gives us a value that's shorter or less than 88 million. We want 88,500,000, right? And since the question is how many folds will require for it to be taller than, so then 27 would be the number, because 27 gives us 134 million. So the answer to this question is it takes 27 folds to be taller. Hard to believe, right? Than Mount Everest. It's not going to fit on my screen here, so I'll just put to be taller, but we know we're talking about taller than Mount Everest. Okay, so that's letter C. Okay, so we're going to go through these list of functions. Some of them are explicit, some of them are recursive, and say yes or no whether they would fit this table. Again, we're missing the first values. We're missing values after 7, after n equals 7. So for A, 2 to the n, f of n is 2 to the n. Well, we could simply just plug in the n equals 4. And so 2 to the 4th is 16, which does not equal 6, right? So this is no, because 2 to the 4th does not equal 6. The next one, B, 3/8 times 2 to the n. Well, is the ratio 3/8? So we're going to take the 12 over 6 to get the r. Let's see. And we get 2. Before I go on, let me just make the table starting at 0, just going backwards. So for n is 4, we have 6. We cut 6 in half, that gives us 3. We cut 3 in half, that gives us 3 halves. We take half of 3 halves, so half of 3 halves is 3/4. And then we take half of 3/4, and that gives us 3/8. So we're going backwards, okay, to recreate the table. So B says that the initial number is 3/8. Well, it would be 3/8 if A is 0. So this one I'm going to say yes if we begin with n equals 0. Because there it is, 3/8. For part C, we have f of 0 is 6. Well, right off the bat, right there, we see that it's not true, right? F of 0 does not equal 6, it equals 3/8. So this one is no. Because f of 0 does not equal 6. For D, if we begin with n equals 1, we do get, if we start off with n equals 1, we could get this list. Remember this, I started on 0 just in case they started on 0, but if they start with 1, if we begin with n equals 1, then yeah, this would be a valid equation or a valid formula. then yes. Okay? Because if I started with n equals 1, yes, I would have a 3/4 as my first number. For letter E, f of 0 is 3/8. Okay, so far so good. I'm looking right here. F of 0 is 3/8. And then the ratio is 2. It's right there. And that's the right formula for a recursive, right? So this is yes, because it all works out. For letter F, we have, if f of 1 is 3/4, again, if we begin on n is 1, we could ignore this part for now, because again, we don't know. We don't know. This is just dot, dot, dot. But here, if we assume that we start with the first one, which is this one, then f would be true. Okay? For G, it says that the ratio is 2, and that the first number, now 1.5, remember, is the same thing as 3/2. 3/2. So this would also work if our table began with n equals 2. Because so this would be yes if we begin with n equals 2. Oops, I forgot the n. With n equals 2. And again, it could. The only reason I started with 0 is to cover all our bases, to make sure we have all the possible numbers. But this table could start with 2, because we don't know. And then for H, the ratio is 2, right here, and the first number is 3. So there is a 3 on our table right there. And if I put a 3 here for n, 3 minus 3 is 0, so 2 to the 0 is 1. 1 times 3 is 3. So this one would also be true if we begin with n equals 3. Okay? Because it doesn't tell us where it starts. So I just wrote all of the numbers starting with 0 just to make sure I have all possible numbers. But the table could start here, it could start here, it could start here, or here. That's why I put all the conditions. If we begin with, then yes. Okay, so the ones that could possibly be true are B, B, D, E, the rest of them. So those are true if we begin with those n values that are there.